A busy Linux system can contain a lot of files. How much is a lot? Well, my workstation has more than 1.2 million of them. Tracking down individual system and configuration files is going to be important from time to time, but visually scanning for them one directory at a time can be unbelievably tedious. The quickest and easiest way to find files is using locate. Suppose you couldn't remember where they've hidden the configuration file controlling the way the adduser command works. You could simply run locate using adduser as a parameter. The most likely candidate from the list is the one in the /etc directory, which happens to be where most configuration files are kept. You can then open the file in a text editor by pointing to its address. Locate works so quickly because it simply reads a precompiled index of all the files and directories on the system. If you're looking for files that may have been added quite recently, you might need to update the index. You can do that by running update-db. That'll get you going when you need to find a file. But since pretty much all the action in Linux is controlled through file contents, you'll need a way to search inside those files. As an example, many programs will regularly generate thousands or even millions of text messages that are written to log files so that later you can revisit critical events. To manage the problem of working with all this data, Bash comes with a full set of text manipulation tools for reading, transforming, and redirecting text. We've already seen how less reads a file and displays it one screen at a time. Rather than printing the text directly to the screen, however, you can also search and, if desired, manipulate the contents of a file by sending it through what's called a pipe. Multiple text manipulation tools can then be invoked to filter the streaming text. Here's a simple example. We'll use cat to read the group file that contains information about system groups and that lives in the /etc directory. But rather than just dump its contents to the screen, we'll pipe it to the grep filtering program using the vertical line produced by shift and backslash. We'll tell grep to read through the text and print only those lines that contain the word Ubuntu. If we needed to, rather than printing the output to the screen, we could use it to populate a file. We do this by adding a redirect with a couple of right arrows and the name of a file. Notice how nothing was displayed on the screen, but that it's now permanently included in the new file. By the way, the new file was created as part of the process, but I could have just as easily used an existing file. The only thing is that if I would have used only one right arrow for the redirect rather than two, the text selected by grep would have overwritten any existing contents of the file. Two arrows will append the text to the end of the file. That's an important distinction that you should keep in mind. Since group is a rather long file, this is a good way to illustrate how we can use some more tools. Head, by default, will print only the first 10 lines of a file, and tail will print the last 10 lines. Of course, the real value of a file like group is in the data that it contains. You can see that each line follows a similar pattern. First, a group name, then a colon and an X, another colon and the group ID number. It might be useful to be able to pull out one field of data from each line and process them all together. For that, we'll use cut. -D tells Linux to use every colon as a field delimiter, meaning to consider every appearance of a colon as the end of one field and the beginning of another. -F3 is our way of saying that we're only interested in processing the contents of the third field of each line. As you can see, this successfully printed only the ID number of each group. Good enough? Not yet. Deep down, I'll bet you'd love to see these numbers printed in ascending order. No problem at all. We'll pipe our output to sort-n. And there you go. If you're a descending order kind of person, just add an R, or reverse, to the sort arguments. Okay, while I have to admit that this example was pretty silly, I still feel that there's a certain beauty to squeezing so much function into a single short line of code. Nevertheless, I'm confident that you can see how each of these tools can be really useful when you've got a pressing need to quickly analyze a large text file, like a system log, and you just don't have the time to read through it line by line. One more tool. If you'd like to see how many lines, words, and characters a file contains, run WC, which stands for word count. Since I mentioned redirects using arrows just a minute ago, I might as well finish the job. The word redirect implies that we're handling the text differently than it would otherwise have been managed. How would that normally have gone? Well, that depends on the kind of text it was. You've got three to choose from: standard input, often referred to as stdin, standard output, or stdout, and stderr for standard error. Standard in is normally coming from the keyboard through which it's made available to bash. A standard in redirect would accept input from an alternate source. This example will open the MySQL database engine as the root user and import the mydatabase.sql database file using the left arrow character to tell bash where to find the file. Standard out will by default be sent to the terminal display. Redirecting standard out to a file, as you saw a bit earlier, would work like this. Remember, one right arrow will erase any existing text in the file and replace it with the input, and two arrows will append the new text. Finally, standard error will write any errors generated by a command. By default, those errors will also go to the terminal display. I'll run wget against an incorrect web address for pluralsight.com with 2 M's to illustrate how that would normally work. You can see that wget failed to resolve the address. Hardly a surprise, considering that there is no such address. However, if I'd like the error message written to a file, I'd use wget, the incorrect address, the number 2, a single right arrow, and the name of the file I'd like to correct. The number 2 is a designation for standard error. 0 is standard in, and 1 is standard out. Find this useful? Why not follow the link in the description and head over to view the complete course on Pluralsight. And of course, for even more technology goodness, don't forget to subscribe to this channel.